Hello everyone. The project which we are going to discuss today is a COVID-19 prediction on the basis of using machine learning models. So for this reason, the dataset which we are using is taken from Kaggle website, and it contains the record of different patients and basically different test records which were carried out during the coronavirus period, and it contained different features like headache, fever, and all. So yeah, so moving forward. So first of all, we are importing all the necessary libraries which are required in this project, and the most important is the pandas. And after that, these are the imports of our machine learning models like random forest logistic regression, which we are going to use in our projects. And these are some visualization libraries, and these are some imports for performance metrics like ROC score, accuracy, and precision and recall. So moving forward. And the first step which we are doing is like we are importing our dataset. Our dataset is present in the same directory in which our notebook file. So I'm just importing with the name of the dataset file like COVID-19 datasets or .csv. So our data is in CSV format, so we are using read underscore CSV function of pandas. If our data will be in XLS format, Excel sheet, then we have to use read XLS function of pandas. So moving forward, now we are checking the head of our dataset, like the first 10 records of the dataset, to know more about the data, like what type of data is present in our dataset. So here we can see that it has around 10 features and 2.7 million records, which is a lot record. So this data can be considered as a big data, and our model can train well on this type of data because the number of records are too much. And uh, this is a good thing because the more the data, the more the learning for the model. So now moving forward, so in the data dot head, we can see that we have different features like cough, fever, sore throat, and shortness of breath, headache, and corona results. So this is our target variable which we are going to predict in this project. And after that, age is 60 above or not, and gender is male, female, or any other, and test indication. Test indication is like from where the patient contacted lastly, like if he come from abroad, or other if we don't know where he came from, and abroad if he came from abroad, or contact with confirmed means like if he contacted with the person who already has a confirmed COVID-19. So yeah, moving forward, and now we can see that for the distribution of a target variable, which is the corona result, we can see that around 260,000 records are having negative results. Negative here means that the patient don't have a coronavirus, and around 14,000 are having a positive results, and around 3,800 are the others, like we don't know about that. So moving forward with the data preprocessing. Data preprocessing is basically a very essential steps in the machine learning project. So before applying any machine learning models, we have to preprocess the data and need to validate it according to the machine learning so that we can apply on it different models. So first of all, the first thing I'm checking the shape of the data. Like shape is as I have already tell that 2.78 million and 10 features. And after that, I'm checking the data type of the columns. So in machine learning, before applying machine learning, all our column must be in integer format, in a numerical format. So right now it's showing that all our features in string format, means textual format. So we have to convert these features into a numerical format. For that, we are performing data preprocessing. And here I'm checking the different statistical features of our data, like how much count and how many unique values, and what is the top value and what is the frequency, and all that of the numerical features. So now I'm checking the null values, like if our data contain any null values or any irregular values. So luckily in our dataset we don't have any null values, so we can move forward. And I'm dropping the unnecessary features like test date, which is not contributing and which will not contribute anything in the model prediction. So we can drop this. So dropping the date column, and now moving forward with the head, and now we have a 9 features as we have dropped the date. And moving forward to the, now I'm checking the unique, how many unique values did the cuff which I have, like it is showing that 0 1 and 0, this to 0 is in the string format, as we can see. That's why in above it was showing this column also in a string format because of these values 0 and 1 and none. So we have to convert this into a 0 1 format. So what I'm doing is, yeah, I'm using pandas replace function to replace string 0 with the numerical 0, and replacing 1 with the numerical 1, and replacing none with the 0, because I'm considering none also as an negative feature. So uh, uh, so after that, I have converted the cuff into 0 and 1. So now our cuff feature only have two values, 0 and 1, because I have converted this 0 1 none to 0 and 1. So now moving forward, same thing we are doing with the feature, because fever fever feature also have the same issue of string 0, string 1 and none. So similarly, I repeat the same step for this feature as well, and convert it into a 0 1 format. So similarly, source hood also has the same issue, and breath shortness also have the same issue. So we are applying again. Headache also has the same issue. So as now we have converted all the features into a 0 and 1, now we are converting into a 2 numeric. Like now we are converting these features into a numeric format using a pandas function of 2 numeric. So after this step, our features will be converted into a numerical format officially. So now again I'm checking the data types, and here we can see that our five features are converted into an integer format, which is a numerical format. And after that, our target variable, checking the values of a target variable, here it is showing that negative, positive and others. So we have to convert this negative, positive and other into a numerical format, into a number format. So for that reason I am using a label encoding mapping, and mapping numbers to a values, like I am assigning negative value to a 0, positive to 1 and other to 2, and then converting the feature corona result into a numerical format. So moving forward, so as you can see that our target variable has three different classes: negative, positive and other. So we can say that this is a multi-class classification problem in which we have multiple classes other than two. So if it has only two classes like positive and negative, then it will be a binary classification problem, but it's a multi-class classification problem right now. So now converting into a numerical format, and moving forward with the age 60 above column. So in this we should have only two values, yes, no, but it also has none. So for that we are also using label encoding and assigning no to 0, yes to 1 and none to 0, and again converting into a numerical format. So similarly, we are doing label encoding for gender and test indication, and converting all the features into a numerical format. And now I am checking the data types of the column. As we can see that it's converting into integer format. So now all our columns are in the numerical format which we want before doing any machine learning. So here what I'm doing is I am considering the other value in our target variable, which was other as a negative result. So I am replacing 2 with 0. So now our target variable only has a two classes, 0 and 1. So now it's a binary classification problem, not a multi-class classification problem. So after that, I'm performing some exploratory data analysis and doing some visualization regarding to this project, and to get some more insights about the data. So uh, now I'm first of all checking the distribution of the target variable. Like most of the records are negative records, like 95% records are negative and only 5% records are positive results. So we can say that it's quite imbalanced data set, because one class is more as compared to the other classes. Yeah. So moving forward, and here are checking the distribution in the form of numbers, and now checking the gender, like number of male and females are almost equal in the dataset, like 120,000 males and females, and the other gender is like quite low. It contains only 20,000 records. So moving forward is the feature ratio. So most of the patients don't have any features, and some are having features, like 250,000 people, more than 250,000 people are not having any fever, sorry. And test indication graph, here we can see that it is also like for other there are a lot of values with the other, and there are uh, this one is for abroad, and this is for the confirmed contact with the patient. So moving forward with the graphication, now I am plotting the correlation plot. So correlation plot basically tell us about the feature which are highly correlated with our target variable. So we can see that our target variable is corona result. So we can see that headache is highly correlated with the corona result, and test indication is highly correlated with uh, corona result target variable, as it is showing a 0.48 correlation. Similarly, all the features are somehow correlated with each other. So moving forward, now I am splitting our dataset with the 70-30% ratio, and creating a test and train X and test X sets before doing machine learning. So in this step, what we are doing is I'm assigning all the features except our target variable, which is a corona result, into a X variable, and our target variable will be in a Y variable. So I'm assigning this and then splitting our dataset into an XY, train X test X and train Y test Y sets. So we have divided our dataset into a tainted test sets, and after that, here are all the features column names on the dataset. So now the next main step is to apply machine learning models. So for machine learning model, the first model we are going to implement is logistic regression model. And in logistic regression, we are applying first of all applying k-fold cross validation in the model, and k-fold cross validation basically tell about that how our model will perform, how maximum our model can achieve on this data set. So here I am using 10K fold cross validation, and it is showing me that the average accuracy of logistic regression will be 96, and the maximum it can achieve is also a 96.2. Yeah, so and this is basically a confusion matrix of this model, which tell about that how much prediction are truly predicted by our model and how much prediction are made false by this model. So yeah, so now uploading our logistic regression model, and here predicting different metrics, performance metrics for the model, and we can see that we have computed a confusion matrix, AUC score, accuracy of logistic regression, which is coming as a 96, and recall precision is also good, and specificity, sensitivity, miss rate, and here is the F1 score. Here you can see that the F1 score and ROC curve for this, and here are the it is telling about the feature which are highly performing, highly contributing in this model. So we can see that two of the features are not contributing anything, and the cuff feature is negatively contributing in this model. So yeah, so now again applying a different model XGBoost classifier, and similarly I am applying the k-fold cross validation first, and after that I am applying a XGBoost model, which is a boosting model, and calculating different performance metrics for it, and after that I am applying a decision tree classification model, and the procedure is basically same, but the code for decision tree model is different. And so after that I'm getting a 96.74 decision accuracy with decision tree, which is quite good. And after that I am applying random forest classifier and applying first k-fold cross validation first with this, and similarly after k-fold cross validation I am applying a random forest classifier and calculating different metrics with it and getting an accuracy of 96.75, which is also very good. And after that I am applying a naive based classifier, and the accuracy we are getting with the naive based classifier is 94.6, which is quite less as compared to the other models. So similarly with the gradient boosting model, and the accuracy we are getting with the gradient boosting is 96.74, which is quite similar with the decision tree. And in the end I am applying an ensemble model based technique. So ensemble technique is basically which in this we combine our different best performing models into a one model, and made a one model with the different high performing model of our project, and create a one model, more powerful model, and then do prediction with these and check the accuracy. Like I'm getting an accuracy of 96.73, which is quite similar to XGBoost in decision tree. So we can see that with the voting classifier we are not getting very much high accuracy. So our voting classifier is also performing good. Like 96% is also a good accuracy, but our base models are also getting similar accuracy. So after that, I'm doing some feature selection and selecting the best performing feature out using a correlation matrix technique. So here from the correlation matrix, we can see that we are selecting our best performing feature which are highly correlated with our target variable. So in the corona result, we can see that the headache is highly positively correlated with the target variable. So we are adding headache. So similarly, we are adding all the features in the X which are highly correlated with the target variable. So similarly, now we are again applying different machine learning models and getting the highest accuracy with XGBoost basically, which is 0.966. So yeah, so after that I'm applying voting classifier again, and with again when you apply voting classifier, its accuracy is 96.60, but before feature selection its accuracy for was 96.7. So we can see that after feature selection our model accuracy decreased a bit. So the result before feature selection were better as compared to the result after feature selection. So here is our application.py file which we are using in this project, and here basically a backend of the Streamlit API, Streamlit app on which we are doing different prediction for the COVID-19, and this is the backend. And for the to check the front end, we are we have to open our command prompt, and so we have to write cmd in the directory in which the notebook file and the model file is present. So here I am writing cmd and type streamlit one app.py. So it will open the Streamlit app for our model. So here we can see that it's showing COVID-19 detection. So we can add different values in these features and then uh, press a button of predict to check the result of the COVID-19. So this is basically a front end of it's a quite simple front end, but the back end is and the model which we are implementing is very strong. So I hope you like our project, and this is basically our project for the COVID-19 detection. And this is it about our project, and thank you very much.